So in the previous lecture, we have discussed about the textual representation of data, the tabular presentation of data, and even in diagrammatical presentation of data. We have discussed about histogram, which is under frequency diagram. So under this diagrammatical presentation of data, we have frequency diagram. So again, in frequency diagram, we have what is called histogram, and then frequency polygon, and then frequency curve. And we have discussed what is a histogram and the basic difference between histogram and a bar diagram. So as we have seen here, this is the example or the presentation of histogram in the graph. So here we can see that it is a continuous variable that we are plotting in the graph, and that there is no gap between the bars. So and with the help of this histogram, we are able to find out the mode of the data. Mode would mean the maximum number of observation that happens. But as we can see here, this is an example of a bar diagram. So in bar diagram, so there is a gap between its bars, and this gap is taken arbitrarily. So there is a big gap, or continuity is not maintained here in the case of bar diagram. But in case of histogram, there is no gap between the bars. So there is some of the basic difference between bar diagram and histogram. So we go ahead to explain what is a frequency polygon. So actual, or in simple term, frequency polygon is the plane bounded by straight lines, usually 4 or more lines. So it is a bounded plane. It is a plane, bounded by all the straight lines in 4 sides or more. And it is an alternative to histogram, and is also derived from histogram itself. So this frequency polygon is an alternative to histogram, and it is actually derived from out of histogram. So how do we derive from histogram? How do we derive frequency polygon from histogram? So the simplest method of drawing a frequency polygon is just to join the midpoints. We have to join the midpoints of the top side of the histogram. So if we join all the join midpoints of the top side of the histogram, then what we get is a frequency polygon. So frequency polygon is the most common method for presenting group frequency distribution. So for group frequency distribution, we often use frequency polygon. So when comparing two or more distributions plotted on the same axis, frequency polygon is likely to be more useful, since the vertical and horizontal lines of two or more distributions may coincide in a histogram. So instead of histogram, we often use frequency polygon because of this advantage over histogram. So this is an example of a frequency polygon. So this is similar. We can say this is a frequency histogram, let us say. So how do we obtain a frequency polygon? Is we just join the midpoints of all the bars of the histogram, and what we get is a frequency polygon. So that is how we derive frequency polygon from a histogram. And what is a frequency curve? Frequency curve is nothing but a smooth hand drawing of a frequency polygon. So this was the frequency polygon. Underneath is a frequency curve, because we are drawing this curve in a freehand manner, joining all the points possible. So frequency curve is obtained again by drawing a smooth freehand curve, passing through what? Passing through the points of the frequency polygon as closely as possible. So we derive frequency polygon from histogram, and again we derive frequency curve from frequency polygon. So what is a frequency curve? It is obtained by drawing smooth freehand curve, passing through the points of the frequency polygon as closely as possible. So these are the type of presentation of data which comes under frequency diagram. And we move on to what is called arithmetic line graph, the last one for diagrammatical presentation of data. So before going that, I will give you a video which will explain you to draw an or give for less than and more than data. So or give comes under frequency diagram, but we will discuss that in the video which I send you. So what is an arithmetic line graph? So it is given here. An arithmetic line graph is also called time series graph. So both arithmetic line graph and time series graph, they are the same. So in this graph, in this arithmetic graph, what we do, time such as hour, day, date, week, month, year, etc. are plotted along the x-axis, and the value of the variable, that is time series data, along the y-axis. So in the x-axis we are plotting the time series, and then on the y-axis we are plotting the variables of the series of data. So a line graph, by joining these plotted points thus obtained is called arithmetic line graph or time series graph. So after plotting the time on the x-axis and variables on the y-axis, the line graph or the graph, a line graph by joining these plotted points thus obtained is called an arithmetic line graph or time series graph. So this is an example of an arithmetic line graph or time series graph. So along this y-axis we are measuring or we are plotting year, that is from 1993 to 2014. So we are plotting the year, that is time series, on the x-axis, and on the y-axis we are plotting the values or the data series, that is here we are measuring the export and import value over the years, over this year. So what can we see from this data? So from this figure 4.9 we can see that for the period of 1993 to 94 to 2013-14, the imports, this is imports, okay, with the boxes, lying with the box, the imports were more than the exports all through the period. So through this arithmetic line graph we can see that this imports is higher in all the years than the exports. So again you may notice that the value of both exports and imports rising rapidly after. So they are started to rising rapidly, both import and exports, from the year 2001 and 2002. So in this diagram, that is arithmetic line graph, we are plotting imports and exports values over the years. So what we get by joining all the plotted points, what we get is a arithmetic line graph or time series graph. So by just looking at this arithmetic line graph, we can explain what is happening here, and we can see that exports is much lesser than imports all throughout, and the level of import and exports keeps on rapidly increases after 2001 and 2002. So this is the information that we get from arithmetic line graph. So in conclusion, what do we do? By studying this lesson, you must have been able to learn how data could be presented using what various forms of representation such as textual, tabular, and diagrammatic. And then you are now also able to make an appropriate choice of the form of data presentation as well as the type of diagram to be used for a given set of data. So what sort of presentation of data should you use for different set of data, you must be able to know. So you can make presentation of data meaningful, comprehensive, and purposeful after studying this data. After studying this chapter, that is presentation of data. So as I have said, I will be sending you a video how to construct a or give presentation of data for less than and more than.